Okay, so this is the last day of notes for Chapter 4. This one's all about isosceles and equilateral triangles. So triangle WXY is congruent to some triangle by angle side angle. So WXY is the top of all the triangles in this figure. And we are given that angle W here is congruent to angle V. Side WX is congruent to side VZ. And angle X is congruent to angle Z. So we have our angle, side, angle like we need. So now we just need to name it properly. Since angle W matches with angle V, V will be the first part of our name. Since angle Z matches with angle X, that's going to be the next part of our name, and then the only part of the name that is the same vertex, Y. So for our next one, we're looking at WYZ. That's the triangle to the left of this figure. And so we're looking for angle side. We know that these angles in the middle are congruent here because they are vertical angles. So that's one angle. And we're also given an angle W and an angle V match. And we are giving our side with the 2 marks. So we have our angle, side. So now we just, again, need to name it properly. So angle W still matches with angle V. Angle Y is the common one between the 2 triangles. And angle Z matches with angle X. Now the last one, we're looking for side, side, side. And I'm going to trace out the triangle that they're talking about because it's not as obvious of a triangle as the others. So VWZ is this triangle that is about half of the entire figure. So obviously the other half is probably the common one, and we can say that it is because we know that we have this side matching with this side over here. We have WZ matching with XV, and then the middle side is shared between the 2 triangles. So now once again, we just need to name it properly. Angle V matches with angle W. Angle W matches with angle V. And angle Z matches with angle X. WVX. It's not a U. There is no U in this. Alright. So, vocab for today: legs of an isosceles triangle, vertex angle, base angles. So here we have the isosceles triangle theorem. This basically says if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. And the converse is the other way around. If 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So here we have this figure. We want to name 2 unmarked congruent angles. We have 2 angles that are marked that are congruent, but we also have 2 sides that are marked as congruent. CB and AB. And since those are congruent, that means the angles opposite of them are congruent, and those are our 2 unmarked angles. So now we just need to name them. So angle BCA is congruent to angle BAC. Yeah, that's it for that problem. Pretty easy. So, equilateral triangles. A triangle is equilateral if and only if it is equiangular. So it has to have angles all the same. And we know now from the last set of notes that all the angles of a triangle sum to be 180. Not the last set of notes, but a couple notes ago. So if we think about it, 180 divided by 3 angles of a triangle, they should all be 60. And that's what the second one says. Each angle of an equilateral triangle measures 60 degrees. So, here's a triangle given to us. We need to figure out the information. We need to find the measure of angle R. So we're looking for this angle down here. We know that since these two sides are congruent, they're both 5, the angles opposite of them are congruent. Now, we know one of the angles is 60, correct? So, we take that away from the 180, we know the sum of all the angles are. We get 120. And we're going to take that 120 and divide it evenly, because we know these angle P and angle R are congruent, by 2. So 120 divided by 2 is 60 degrees. So we do indeed have an equilateral triangle. So since it is equilateral, part B wants us to find PR. We have two sides given to us as both 5, and we now know it's an equilateral triangle, so that means that PR is also 5 centimeters. Okay, our next one here, same idea, just different numbers. Once again, we know these two sides are congruent, so the angles opposite of them are congruent. So, since we know that the angle opposite of TR is 60, then angle T is also 60. And TS, since we now know that two of our angles are 60, the only thing left is another 60 degrees for angle R. So that means all of our angles are 60, so it's equiangular, which means it's equilateral, which means that TS is the same as the other two sides we already know, at 3.5. Last problem. So now we need to find both variables. We know that two sides are congruent, they're marked that way, and because of that, we also know that these angles are congruent, and the angles are given to us as 4x minus 8, angle F and angle E. Since angle E is congruent to angle D is also 4x minus 8, which means we have an equilateral triangle. So when we want to find x here, all we have to do, remember, all the angles of an equilateral triangle, they add to be 180, but because it's equilateral, they're all 60. So 4x minus 8 is equal to 60. So we add 8 to both sides, and 4x is equal to 68. We divide by 4. And x is 17. Now, y, a little bit different. We know the two sides are congruent, but they're different expressions, so we need to set them equal to each other. 8y minus 5 equal to 6y plus 3. We subtract 6y from both sides, so really we're just adding this one step in for this problem compared to the last one. So we have 2y minus 5 equal to 3. Now we're going to add 5 to both sides. So 2y is equal to 3 plus 5, which is 8. We divide by 2. 8 divided by 2 is 4. And that's it for this video. Only thing left, we did get onto Google Classroom before, but you don't need to worry about that now. If you aren't already on it, then yeah, you probably won't be able to find these videos. So, here is our exit ticket. Find x and find y. X is super easy to find because we can tell that it is equilateral triangle.